Howdy. In this video, I'm going to show you how to do the covariance calculations, again, using built-in functions and some step-by-step calculations. All right, let's get to it. This is the covariance formula. We have seen something similar for the correlation. So first I'm going to calculate AI, BI, and then N times A bar, B bar. These are the averages, and I'm going to actually start from the averages. And average is these 17 numbers and these 17 numbers again. So next AI times BI, and that is equal to this multiplied by this value, right? And then copy formula to the all cells. Let me kind of color code this one. And then I'm gonna say sum. All right, and this area gonna be the sum function. All right, sum of, so I get the sum of IIBIs, and then N, I know 17 observation, A bar, B bar are there, and -1, so I can calculate the covariance. And that is equal to, I'm gonna do it in parentheses, sum of AI BI minus 17 times A bar times B bar, and then divide by N minus 1, that is 16, right? That is covariance. Right, I could also calculate the covariance using the built-in function, covariance. And there is like population and then sample. I'm gonna use the sample because we have only the sample here, and for that, similar to the correlation, I'm gonna just select array 1, array 2, and then finish it. So they are both the same number. I think I am good. And then the third way is the relationship between correlation and covariance. I'm just gonna go from covariance to the correlation, and we can check it the same way later. A comma B, and let me select these, format them, subscript. All right, so covariance is divided by standard deviation A times standard deviation B. Set it as standard deviation here. I remember these are the sample standard deviation. So standard deviation sample again is 17, and we had calculated this one earlier, so similarly this is the number. So correlation is equal to covariance divided by multiplication of this one and this one, right? 81. And finally I can do the correlation again to see if these are basically coming up to be the same number, and I'm sure they are. All right, so we did calculate the covariance and then the correlation. Here, as the covariance gets higher, the relationship or the relationship between two factors increases as well. Covariance changes between minus infinity and positive infinity, and as just mentioned, higher the number, better, right? Correlation, though, it's going to be only between -1 and 1, so there is a scaling thing here. I wouldn't really know where this number stands for. Is that a good correlation or not very good? Perhaps the scale is in millions, so in that case this 1798 would not be a good correlation or a relationship, right? So that's it.